HACCP is an acronym for Hazard Analysis Critical Control Point. The HACCP system is used in the field of food safety. In other words, it's used in the manufacturing, packaging and also in the catering. The HACCP method can also be applied to other fields, such as the cosmetics or pharmaceutical industry. This tool is used to control the quality of foodstuffs or manufactured products. The HACCP focuses on three types of hazards. First, biological hazards, such as viruses, bacteria, or parasites. Secondly, chemical hazards. For example, pesticides, products resulting from the manufacturing process, additives, or drug residues. And finally, physical hazards like wood, glass, metals, or hair. Before applying the 7 principles of the HACCP method, we have to lay the foundations with the 4 initial steps. The first step is to assemble the HACCP team. The goal is to bring together company staff from different departments with the required knowledge and experience, and who are involved in the control of health safety. For example, staff members from the quality team, production, research and development, purchasing, marketing, or maintenance. All these people can be useful for reflection. The second step is the product description. This involves describing the components of the product and its storage conditions. If we take the example of a pasteurized apple juice, we should detail its components. In other words, we need apples, to which we add water. Then we also detail its specifications: sugar-free, and with an intake of 0.3 calories per milliliter. Finally, we can also add its preservation methods. For example, storage in a refrigerator at a temperature between 4 and 8 Celsius degrees. When describing the product, it is also necessary to define its use, by indicating, for example, that the drink can be drunk directly from the bottle. Likewise, the targeted consumer category can also be specified. For example, the drink may not be adapted to the consumption of infants, or not recommended for patients with hypertension. Finally, we can add information such as the best before date, or the expiry date. The next step is to determine the manufacturing process. The manufacturing process is divided into different steps, starting with the receipt of raw materials, up to the storage and shipping of finished products. This is called the process flow chart. The fourth step consists in verifying the conformity of the manufacturing diagram. In this phase, we must confront the diagram with the reality of the field. There are often gaps between theory and practice. This action may, for example, allow to highlight the absence of cleaning of the work plan between 2 steps. Any differences found during this phase must be included in the manufacturing diagram in order to be as representative as possible. Once these 4 initial steps are in place, we can move on to the 7 principles of the HACCP method. The first principle of this method is the hazard analysis. The aim is to analyze all the potential hazards associated with each step, and define the means to control the identified risks. To do so, it's necessary to identify hazards at all stages of production. Then, estimate the probability of occurrence of these hazards. And finally, determine preventive measures to put in place to ensure the control of hazards and food safety. The second step of the HACCP method is the identification of critical points, also known as CCP. What is a CCP? A critical control point is defined as a step where control can be applied. This control point is essential to prevent, eliminate, or reduce a hazard to an acceptable level. Potential hazards that could cause illness or injury in the absence of controls should be considered when determining CCPs. Determining a CCP can be facilitated by applying a decision tree. The decision tree consists of a systematic series of 5 questions, designed to objectively estimate whether a CCP is necessary to control the hazard identified at a given stage. The first question that should be asked is there any hazard at this step? If there is no hazard, it isn't a CCP. If there is an identified hazard, we can move on to the next question. For the identified hazards, are there preventive measures? If there are no preventive measures, we have to know if preventive measures are necessary for the safety of the product. If a health hazard has been identified, but no control measures are in place, the process must be modified at this step or another to introduce a control measure. Control measures may include, for example, temperature control, visual examination, or the use of a metal detector. However, if the hazard doesn't affect the safety of the product, it isn't a CCP. If there are preventive measures for the identified hazards, then we move on to the next question. Is this step specifically designed to eliminate the likelihood of a hazard, or reduce it to an acceptable level? If so, we have a CCP. The following examples describe procedures or operations designed specifically to control identified hazards. These may be sterilization of food in a cannery, pasteurization, chlorination of cooling water, installation of a metal detector on a manufacturing line, or a specific cleaning and disinfection procedure. It is necessary to define acceptable and unacceptable levels while taking into account the objectives of the CCPs. If we answer no to the question, does this step eliminate or reduce the hazard to an acceptable level, we move on to the next question. Can the hazard increase to an unacceptable level? Or can contamination occur? In other words, this question refers to the probability and severity of the hazard. In order to answer, this judgment involves a hazard analysis that must be based on all the information collected. If the contamination is not likely to cause a significant danger to human health or is very unlikely, then this is not a CCP. Nevertheless, if a thorough study suggests that contamination by the identified hazard may increase to an unacceptable level and lead to a health hazard, we need to move on to the next question of the decision tool. Can a later step eliminate the hazard or reduce it to an acceptable level? The purpose of this question is to identify hazards that threaten the safety of the product, but which can be controlled by a later stage of the manufacturing process. If there is no subsequent step or operation in the process to control the identified hazard, then this step is a CCP. In contrast, if there is one or more subsequent operations that eliminates the identified hazard, or reduces it to an acceptable level, it isn't a CCP. To illustrate the notion of what a CCP is, let's take the example of a chocolate pastry preparation. During the preparation, a piece of glass may end up in your cake. This debris can be present either because when beating the white eggs, the container used is made of glass and has a small chip, or because when the whisk hits at a point, a shock occurs and pieces of glass are introduced into the preparation. Obviously, you don't realize it and you continue the recipe by incorporating the chocolate. When analyzing hazards, you know it can happen because you work with glass containers. Therefore, this physical hazard of having a piece of glass in your chocolate pastry is possible. You could eliminate this risk if you had a machine that can detect glass in your preparation. In this case, this risk is not a critical point to control because you have the possibility to detect it. Eventually, if you decide to make an investment and replace your batch of glass containers with stainless steel ones, then you will completely eliminate the physical risk of finding a piece of glass in your chocolate pastry. Nevertheless, if you do not possess a device that can detect the pieces of glass, or if you have no intention of replacing your batch of containers in the near future, it's a critical point to master. You'll have to be extremely careful with the glass containers when preparing the chocolate pastry. After analyzing the CCPs, the critical limits should be established. A critical limit is a criterion for distinguishing between what is acceptable and what is not. For example, we can set critical limits for the temperature, the duration, or the pH. Once the critical limits are set, we have to move to a monitoring system. Analyses and measurements must be performed, formalized and recorded to ensure that CCPs are properly controlled. This may include, for example, the continuous control of the temperature of a cold room with an alarm if the thresholds are exceeded. During the monitoring phase, deviations are usually detected, which leads to corrective action. This step consists of implementing the necessary and immediate corrective actions that machine operators, managers, can implement. These corrective actions must be recorded. Once the HACCP system is in place, it's necessary to use methods, procedures and analyses beyond monitoring to determine compliance with the plan. For example, by implementing equipment control procedures, measurements, sampling, or random sample analyses. Lastly, remember to keep records and put in place a documentation system. The purpose is to prove that the provisions of the HACCP plan are valid and respected. This system must remain simple to be easily exploited by those who use it. Let's review together the key steps for a successful HACCP process. In the initial steps, we have the composition of the HACCP team, the description and the use of the product, the process flow diagram, and the comparison of the diagram to the reality. Then, regarding the 7 principles, we have the hazard analysis, the determination of CCPs, the implementation of critical limits, the establishment of a monitoring system, corrective measures, records keeping and establishment of a documentation system. And that concludes our video. Thanks for watching and see you soon for new content.